Hey, here's another screencast. This one I'm calling confidence interval small sample. In this screencast, I will do an example of calculating a confidence interval with a sample of small size, and I'll show you how to use R to support those computations. Here's the problem. A quality control engineer gathers 10 widgets from the manufacturing floor and weighs them. They've got weights listed here. You can see there's 10 numbers, 8 in the first two rows, 9, 10. And these are weights in grams. Can you use this data to calculate a 90% confidence interval for the expected values of a widget's weight? So how do you go about answering this question? Can you use this data to calculate a confidence interval? Well, let's see here. We've got 10 widgets. 10 is less than 30. So this is a small sample. Okay. And it's smaller than 30. So we're going to have to use the new method of using a student t-distribution to do it. And let's see, what do we need to know about that? Well, first of all, let's just make a note. We're going to use the student t-distribution. And with the number of degrees of freedom is going to be 1 minus the number of elements in our sample. So we've got 10 things in our sample, so our degrees of freedom is going to be 9. So if we can do it, this is the distribution that we'll use. So how do we know if we can use it? Well, that's right. We need to know that this data looks like it comes from a normal distribution. So this is the question. Does data look normal? And this is really a qualitative process to decide if something looks normal. The two things you look for are, does it have outliers? Because outliers are very rare in normally distributed data. So if it has an outlier, then the answer is no, it doesn't look normal. And another characteristic of normal data is it's symmetric. Does the data look symmetric? So the tool of choice for this is a box plot. We're going to calculate a box plot. And when we do it, we want a box plot that looks sort of like this. So the whiskers are going to have roughly the same length. And then these distances here are going to be the same. That is, this bar that represents the mean looks like it's going to be in the middle of the box. If our box plot kind of looks like that, then we'll be happy. If, on the other hand, our box plot looks like this, that's not very symmetric at all. And so we're not going to be happy with that. Or if our box plot has outliers, these aren't going to be good for us either. Okay, so we need to take this data and make a box plot. And so, of course, we're going to use R for that. R is built for that. We don't want to do this by hand if we can't help it. So before we move to R, what else do we need to be prepared to do? So unless we see these bad situations, if everything looks okay, right, this is the okay situation, these are bad. Unless things look bad, we're going to calculate a confidence interval. If the data looks good, we'll calculate, and we'll use R if we can, the endpoints of our confidence interval. So those are going to be the sample mean plus or minus the t-distribution with 9 degrees of freedom and the alpha over 2 times our sample standard deviation divided by the square root of 10. So what do we need to calculate? We need to calculate this from our data, We need to calculate that from our confidence interval, and we need to calculate that from our data. So we need the mean, the sample standard deviation, and alpha. Now, we don't need to use R to calculate alpha, right? So the alpha level, that's easy enough. 100 times 1 minus alpha is our confidence level, and we want a 90% confidence. So we get alpha equals 0.01. And we'll use alpha over 2, so that's 0.05. All right, well, now let's go to R and calculate this, and we're also going to look at the box plot and cross our fingers that it looks okay. Here's my RStudio. You're looking at the editor in the top left, and the bottom left, you're looking at the console, and over on the right, this is the pane where plots will appear. I've taken a moment and copied in the data from the problem, and I'm assigning the data to a variable x. So let's make sure that that's in R's memory by entering. You see down here in the console it is. Now, the first thing we want to do is just, before we invest any other time in this, let's make sure that our data looks symmetric. So I'm going to calculate a box plot using the box plot command. Here we go. Yeah, and there's the box plot. First thing that I notice is that there are no outliers up top, down the bottom, right? The fences stop right there. There's nothing outside those fences, so that's good. The whiskers look like they're about the same length. I mean, this one's a little shorter than that one, but that's all right. And our mean here, or the median actually, is not quite in the middle of the box, but it's not right up along one edge, so that doesn't look so bad. I think this looks symmetric. I think this looks like the data is normal. Nothing really screams that it's not normal, so let's say it's normal and proceed. To calculate the confidence interval, we need the mean. So here's the command for computing the mean of our data. And let's just look at the number, 15.04. Seems reasonable. We'll calculate the standard deviation of our data. And that's command on line 18. And we can look at it. Standard deviation is 0.21. But we really want the standard deviation of our sample mean. That's line 19. And so our sample standard deviation has a value 0.068, 0.069. All right, now we'll build the endpoints of our confidence interval. And I have the formulas for the endpoints down here at lines 24 and 25. Right, we've got the mean plus our t-value times the standard deviation of the sample mean. Right, and I've calculated sigma up here, it's line 20. I've got mu, I calculated that, it's up here at line 16. So let's calculate this quartile for the t-distribution of 0.05 with 9 degrees of freedom. I get negative 1.833115. So I'm making some noise over here because I'm going to look in the book. Alpha of 0.05, we'll go down to 9 degrees of freedom. I look in the book, it's a table for the student t-distribution, and I see the value of 1.833. It's got fewer decimal places of accuracy than R gives us, and it's opposite in sign. If you're concerned about that, you need to go back and watch my previous screencast on the t-distribution to understand why that shouldn't concern you. We'll use R's value. We'll be happy to use it. You'll notice here, because we're using both the positive in line 24, the positive quartile and the negative quartile. But let's evaluate these two numbers here now, 24 and 25, to get the left and the right endpoints respectively of our confidence interval. So there you go. Our confidence interval is the interval of values from 14.91 up to 15.17. All right, we're back to the notes. What did we see? We saw that our sample mean was about 15.04. Our standard deviation, which I'm going to call S, from our data was about 0.217. but then our standard deviation over the square root of 10 was 0.069 approximately. We put those all together. Oh, I guess we have our t-value, our t-distribution with 9 degrees of freedom for an alpha of 0.005. We calculate that to be negative 1.833113. So our confidence interval turns out to be the interval from 14.91439 to 15.16561. Or if we're rounding, we might put that down because the data was given to us with 2 decimal places of accuracy. And that concludes my example. We showed how you go about deciding if some data satisfies the conditions for using the student t-distribution to calculate a confidence interval, how we use R to do that. I showed you the code. Pretty straightforward. If you have any questions, just meet with me during student hours or send me an email. That's it. Thanks for watching.